Hi everyone, I'm Joe Pasquale. This is a submission for a course project. The course is Machine Learning Foundations for Product Managers on Coursera. And this is looking at some data around a combined cycle power plant. So let's understand what we're trying to do here. We're here to predict the electrical energy output of a combined cycle power plant. And what we've been given is a data set of 9,568 readings. Those features include temperature, ambient pressure, relative humidity, exhaust vacuum, and the target here is net hourly electrical energy output. So that's what we're going to try and predict using those other features. So the objective of this project is to determine what type of machine learning approach is needed and an appropriate output metric so we can evaluate the performance of that model. Determine possible features to use in the model and different algorithms we might consider. Create a test set to evaluate the performance of the model and a validation training set for comparing different models. That could be fixed or cross-validation. And to determine which is the best model, let's build a few different types to compare. That could be either using different algorithms or the same algorithm with different features, or the same algorithm and features and different hyperparameters. And then finally, let's just select the best model out of those, the ones we've built, based on the output metric that we've chosen. Okay, so the first thing I did was I looked at the data. By the way, I'm using Google's AutoML tables. I'm not a data scientist, but I found it super easy and quick to use, and it follows the CRISP-DM process. So after looking at the data, there was no data quality, no missing values, no invalid values. The data is very structured and continuous in a sort of time series format. Fairly simple. I don't think there's any need to regularize this data in the first attempt. And we're looking at distributions here. We've got a mix here of normal, skewed and binomial distributions, but there's no real outliers that I can see. And in terms of correlation to our target, temperature and vacuum, they seem to follow a kind of negatively correlated pattern to output, and pressure and humidity a little bit more fuzzy, maybe pressure showing a little bit of a slight positive correlation there. So when it comes to determining what model I'm going to use, I'm going to go with multiple linear regression here. And the reason I'm doing that is I think the problem we're trying to solve here is just a classic case of regressive supervised learning. The goal is to predict a target value given a set of features. I'm going to assume that interpretability is important here, so I want to keep this simple. And linear regression is really just a great model to try first, to apply, to get a benchmark. And then when determining how I'm going to sort of compare this linear regression across different sort of models, I'm going to just try different feature sets. So my first model, I'm going to use all 4 features. My second model, I'll just use 3, pressure, temperature and vacuum. And then my third final model, just 2 features, temperature and vacuum, because they seem to have the strongest correlation to output. The validation method I'm going to use, I'm going to do fixed 80-10-10 split for validation and testing. And my output metric, I'm just going to try and optimize my RMSE, my mean squared error. Given more time and funding, I could have maybe experimented using lasso and ridge regression here. There's a little bit of non-parametric shape to some of the features here, so I might have used decision trees, ensembles, random forests. I could have used different hyperparameters or k-folds for cross-validation and a different output metric, but for now I think I'm happy. I'm going to go with this, and I built my model, and let's see the results. I mean, the great thing with Google's AutoML is it really is very fast, and setting this up, these 3 different models, and I only used 1 hour of training cost for each of these models. It was very easy to do. So I got the results back, and here they are. They're all pretty good. They're all showing what I think are very good scores, output metrics. But the one that's really outperforming all the others is my second model, which was using three features, and I excluded humidity there. RMSE value of 3.026, R squared of 0.969. So, across relative and absolute terms compared to the others, which were pretty close as well, this one just edges out. Which shouldn't be a surprise, right? Because if we go back to the business and we saw the correlation earlier on an earlier slide, we shouldn't be surprised to see that those three attributes would correlate the strongest, more accurate prediction of output. And that should be in line with our understanding on how combined cycle power plants operate. So I would deploy Model 2. I would definitely keep track of its performance as new daily readings come in. I want to make sure that we're not over or underfitting. Maybe we want to sort of do some iteration on this model. But right now I'm pretty happy with it, and thank you. This is it.